This is an educational documentary about the history of technology and biography. The content deals with weapons development in a purely historical and educational context. In 1916, as soldiers died by the thousands in the trenches of World War I, an American mechanic had an idea that the generals considered insane: transforming a hunting rifle into an automatic combat weapon. The military laughed at him. The experts said it was impossible. But John Browning was about to create the most lethal weapon of the 20th century, a machine gun that would forever change the way wars were fought. This is the story of the man who dared to challenge the impossible. John Moses Browning was born in 1855 in Ogden, Utah, into a family steeped in gunpowder and metal. His father, Jonathan Browning, was a pioneer gunsmith who made rifles for settlers and hunters in the American West. The family workshop was attached to the house, and the smell of gun oil and metal sawdust was a part of John's childhood. At 7 years old, while other children played in the streets, John was already at the workshop bench, watching his father's every move. He saw how metal bent under the heat, how parts fit together with millimeter precision, how a simple mechanism could unleash a controlled explosive force. To him, weapons weren't instruments of death, they were mechanical puzzles waiting to be solved. At 13, John built his first complete rifle using only scrap metal found in the workshop. It wasn't just functional, it was superior to many commercial rifles of the time. His father recognized immediately. This boy had extraordinary talent. It wasn't just manual skill. John could visualize complex mechanisms in his mind, understand how forces were distributed through gears and springs, and predict how different parts would interact under pressure. The Browning family was Mormon, and their religion profoundly shaped John's character. He grew up with values of hard work, persistence, and the belief that God gave people talents to be used for the benefit of humanity. John believed his gift for mechanics had a higher purpose. When he was 19, his father died suddenly. John took over the family workshop with his brothers, but it soon became clear that he wasn't just a gunsmith. He was a natural inventor. While other gunsmiths copied existing designs, John began to completely reimagine how guns worked. In 1879, he patented his first single-action rifle. It was revolutionary, simpler, more reliable, and more accurate than anything else on the market. The Winchester Repeating Arms Company, one of America's largest firearms manufacturers, immediately purchased the patent. It was the beginning of a partnership that would last decades. Over the next few years, John created an impressive series of innovations. He developed repeating rifles, pump-action shotguns, and semi-automatic pistols. Each project broke technical barriers that other engineers considered impossible. European manufacturers studied his designs with envy. Hunters and professional shooters competed for his weapons. But John had a particular obsession: creating a truly automatic weapon, a weapon that could fire continuously as long as the trigger was held down. This idea fascinated him, not because of a thirst for destruction, but because of the sheer technical challenge. How to harness the energy of a shot to eject the empty cartridge, load a new one and fire again. How to control recoil. How to prevent the weapon from overheating or jamming. The military at the time wasn't interested. Automatic weapons existed, like the Maxim machine gun, but they were huge, heavy, complex, and incredibly expensive. No one believed an automatic weapon could be practical for battlefield use. John Browning was about to prove everyone wrong. It was an ordinary summer day in 1890. John Browning was at a shooting range, testing one of his new rifles. Each shot produced a cloud of hot gases that escaped from the barrel after the bullet was expelled. John observed these gases with scientific attention, as he always did. For him, each shot was an experiment in applied physics. Then something happened that would change the history of firearms forever. As he fired close to the ground, John noticed the exhaust fumes moving the grass around the rifle. The vegetation bent violently with the invisible force of the gases. It was a phenomenon every shooter had seen thousands of times, but no one had truly observed with the eyes of an inventor. John stood frozen, watching. His mind began to race. Those gases had power, wasted power, power that was simply released into the air with each shot. What if that energy could be captured? What if it could be redirected to operate the gun's own mechanism? He rushed back to his workshop with an excitement his brothers recognized immediately. When John had that gleam in his eye, it meant he'd envisioned something revolutionary. For weeks, he worked on sketches and calculations. He needed to create a system that would channel the gases from the shot to move a piston. This piston would eject the empty cartridge, load a new one from the ammunition belt, and prepare the gun for the next shot, all automatically. It was brilliantly simple in theory, but incredibly complex in execution. The pressures involved were enormous. The timing had to be perfect. If the mechanism opened too early, gases would escape and there wouldn't be enough force. Too late, and the pressure would damage the parts. The gas temperature was another problem. Overheated metal expanded and changed its properties. John began building prototypes. The first exploded on the test bench. The second jammed after 3 shots. The third worked for 20 shots before breaking a spring. Each failure taught him something. John didn't see failures. He saw data. He adjusted dimensions by fractions of a millimeter, tested different metals, and modified spring angles and tensions. His brothers sometimes questioned whether all the effort was worth it. After all, Winchester already bought all his conventional rifle designs. They were making money. Why risk it all on a crazy automatic weapon idea that no one was asking for? But John was driven by something beyond profit. It was the sheer need to solve the problem. It was the certainty that it was possible, even when everyone else said it wasn't. It was the vision of seeing that grass moving with the gases and knowing he had discovered a fundamental principle no one else had grasped. After months of obsessive work, he finally had a working prototype. It was a gas-operated machine gun capable of continuous fire. He tested it in secret, firing hundreds of rounds without stopping. The weapon heated up but didn't break. The mechanism worked like a Swiss watch, even under extreme stress. John knew he had created something special, but he didn't yet know that that moment of watching the grass move would result in the most influential weapon in modern military history. In 1891, John Browning presented his new automatic machine gun to the United States Army. He was confident. The weapon was technically superior to anything else. It was simpler than the Maxim, more reliable and lighter. He had solved problems that other engineers considered impossible. The demonstration was held at a military base in the presence of high-ranking officers. John carefully prepared the weapon, loaded the ammunition belt, and began the test. The machine gun roared, firing with impressive accuracy and consistency. Empty cartridges flew through the air. The target at the other end of the field was completely destroyed within seconds. When silence returned, John expected applause. Instead, he found skeptical looks and expressions of disinterest. One general commented that the weapon was interesting as a technical curiosity, but had no practical application. Another said that machine guns were defensive equipment for fortresses, not field weapons. A third officer simply said that the Army already had Maxim machine guns and saw no need to replace them. John was perplexed. He tried to explain the advantages. Its design was simpler, with fewer moving parts, meaning less chance of failure. It was lighter, making it easier to move around the battlefield. The gas-operated system was more efficient than the Maxim's recoil system. every technical argument was met with polite disinterest. The truth was that the military of 1891 still thought in terms of 19th-century tactics. Battles were decided by infantry, marching in formations, firing in coordinated volleys. Machine guns were seen as specialized equipment for defending fixed positions. The idea that automatic weapons could completely revolutionize warfare had not yet penetrated the conservative military mindset. John returned to Ogden frustrated, but not defeated. He knew his invention was revolutionary. If the American military couldn't see it, perhaps he needed a different approach. He began demonstrating the weapon to private manufacturers and foreign military officials. Some expressed interest, but none were willing to invest in mass production. For years, John continued perfecting the design while working on other projects to pay the bills. He created the famous Colt M1911 pistol, which would become the standard sidearm of the U.S. Army for 70 years. He developed new shotguns and rifles, but the automatic machine gun remained his unrequited passion. What John couldn't have foreseen was that the world was about to change dramatically. In Europe, political tensions were rising. Rival empires were amassing weapons and forming dangerous alliances. Nationalism was inflaming populations. Territorial disputes were creating flashpoints across the continent. It was a pressure cooker waiting to explode. In 1914, the assassination of an Austro-Hungarian archduke in Sarajevo lit the fuse. Within weeks, all the major European powers were at war. World War I had begun, and with it came a form of conflict no one had anticipated: trench warfare. Millions of men dug holes in the earth and faced each other across open fields covered in barbed wire. In this new and terrifying kind of warfare, machine guns suddenly became the most important weapons on the battlefield. And John Browning had just what the world needed. The trenches of World War I created a type of combat no one had imagined. On one side, soldiers took shelter in deep ditches, protected by barbed wire and sandbags. On the other side, just a few hundred meters away, enemies did the same. Between them stretched no man's land, an open field of mud, craters, and death. Traditional military tactics collapsed in the face of this reality. Generals ordered attacks in which thousands of soldiers would leave their trenches and rush toward enemy lines. It was organized suicide. Machine guns positioned in the enemy trenches massacred the attackers before they could get close. In a single day of the Battle of the Somme, the British Army lost 60,000 men, most of them killed by machine gun fire. Machine guns available at the time, particularly the German Maxim model, were extremely effective for defense. But they had critical limitations. They were heavy, requiring teams of 4 to 6 men to transport them. They were mounted on fixed tripods. They overheated quickly, requiring complex water cooling systems. They were composed of hundreds of delicate parts that often jammed in the mud of the trenches. The American Army watched the European war with growing concern. When the United States entered the conflict in 1917, it became clear that they would need machine guns, many of them quickly. American forces were drastically under-equipped. There were only a few hundred Maxim machine guns available, woefully insufficient to equip an army growing to millions of soldiers. It was then that military officials remembered a certain Utah inventor who had demonstrated a machine gun years earlier. John Browning, now 62, was summoned to Washington. This time, the generals weren't skeptical, they were desperate. The news from the trenches was horrific. They needed superior weapons, and they needed them now. John introduced not one, but 2 machine guns. The first was an improved version of his original gas-operated design. The second was something even more innovative, a water-cooled heavy machine gun based on a completely different principle. Instead of using gases to operate the mechanism, it used the recoil of the shot itself. Each time the weapon fired, the barrel recoiled slightly, and this movement activated the reloading mechanism. The demonstrations were spectacular. Browning's heavy machine gun fired continuously for several minutes without jamming. It was simpler than the Maxim. It had only 40 major moving parts, compared to the Maxim's 200. It could be manufactured more quickly and was more reliable in adverse conditions. The officers present were impressed, but there was a critical problem: time. Building factories, training workers, producing specialized tools, establishing supply chains. All of this would take months. American soldiers were being sent to France and dying with inadequate weapons. Every week of delay meant more lives lost. John Browning, at what many would consider retirement age, embarked on the most intense project of his life. He worked 18 hours a day, supervising production, troubleshooting manufacturing problems, and training military gunsmiths. His machine gun needed to function perfectly, and it needed to be in the hands of soldiers as quickly as possible. The race against time had begun. The most fascinating aspect of Browning's design was its unlikely origins. While most military engineers began with wartime requirements and created weapons from scratch, John had taken the opposite approach. His fundamental principles came from observing hunting. Instruments designed for accuracy and reliability in harsh natural conditions. John had spent decades designing rifles and shotguns for hunters. These weapons needed to function flawlessly in the extreme cold of the mountains, the humidity of the forests, and the dust of the deserts. A hunter depended entirely on his weapon. One failure could mean weeks of lost supplies. This demand for absolute reliability shaped Browning's design philosophy. When he observed the gases moving the grass that day in 1890, he was testing a hunting rifle. The revelation that wasted energy could be captured and reused came not from a sophisticated military laboratory, but from a rural shooting range. It was the kind of innovation that could only come from someone who truly understood weapons at a fundamental level, not just as instruments of war, but as precision machines. The gas-operated system John developed was elegantly simple. A small hole in the barrel allowed a portion of the firing gases to be diverted into a cylinder. These gases pushed a piston, which in turn moved the bolt. The bolt ejected the empty cartridge, compressed a return spring, and was then pushed back by the spring, loading a new cartridge from the magazine. The entire cycle occurred in fractions of a second. But simplicity doesn't mean ease. Every component had to be designed with micrometer precision. The amount of gas diverted had to be precise. Too little, and the mechanism wouldn't have enough power. Too much, and the parts would suffer excessive wear. The timing had to be perfect to prevent the bolt from opening, while dangerous pressure still existed in the barrel. The materials had to withstand extremely high temperatures and repeated impacts. John tested dozens of different configurations. He experimented with different gas port diameters, different piston lengths, and different spring tensions. Each variation was tested to destruction, firing thousands of rounds until something broke. Then he analyzed the flaw, identified the weakness, and designed a solution. What emerged from these years of development was a weapon that incorporated surprisingly advanced design principles. The system was self-regulating. If the gas pressure was too high, the piston moved faster, but the recoil mechanism absorbed the excess energy. If the pressure was too low, the system still operated just slightly slower. This tolerance for variation made the weapon reliable even with inferior ammunition or in extreme environmental conditions. Another brilliant aspect was its ease of maintenance. The weapon could be completely disassembled in minutes without special tools. Parts could be replaced in the field. Ordinary soldiers could perform basic repairs. This was revolutionary. Previous machine guns required specialized gunsmiths for any maintenance. John had transformed hunting weapon principles into a weapon of war. But the ultimate test remained. Would it work in the hellish conditions of the European trenches? When the U.S. Army approved Browning's machine guns in 1917, an impressive engineering feat had to be matched by a miracle of industrial production. Manufacturing tens of thousands of complex weapons in a matter of months was a challenge that would test the limits of American industry. The M1917 heavy machine gun, based on Browning's recoil loading design, was the top priority. It had 40 major parts that needed to be manufactured to extremely precise tolerances. Each component had to fit perfectly with the others. Variations of even 1/10 of a millimeter could mean the difference between a perfectly functioning weapon and one that fatally jammed. The US government mobilized industry on an unprecedented scale. Automobile factories were converted to weapons production. Machine tool companies created new, specialized equipment. Metallurgical companies developed special alloys that could withstand the extreme stresses of continuous fire. It was a national effort. John Browning was at the center of it all. He constantly traveled between factories, solving production problems. When workers had difficulty manufacturing a specific part, John redesigned the component to make it easier to manufacture without compromising function. When questions arose about materials, he suggested alternatives. When testers reported problems, he identified solutions immediately. One of the biggest challenges was standardization. Unlike commercial products, where each unit could be slightly different, military weapons required complete interchangeability. A part from a machine gun manufactured in Ohio had to work perfectly in a weapon manufactured in Connecticut. This required rigorous quality control and extremely consistent manufacturing processes. The Colt patent firearms manufacturing company led the production of the M1917. Workers worked 3 shifts, 24 hours a day. Women entered the workforce en masse, operating complex machines and performing quality inspections. Many became highly skilled operators, manufacturing parts with precision equal to or greater than that of the men they had trained for years. Each machine gun was extensively tested before being shipped. Batteries of tests included firing thousands of rounds under various conditions. Weapons were exposed to mud, sand, water, and extreme temperatures. Those that failed were completely disassembled, and the problems were identified and fed back into the manufacturing process. It was a continuous cycle of improvement. Production of the lighter version, the Browning automatic machine gun, BAR, also accelerated. This weapon was particularly innovative. It was light enough to be carried and operated by a single soldier, yet packed automatic firepower. It was essentially the first modern assault weapon, though that term didn't yet exist. Within months, American factories were producing hundreds of machine guns a day. Special trains transported the weapons to ports, where they were loaded onto ships bound for France. Each wooden crate contained a weapon that represented thousands of hours of engineering, hundreds of hours of manufacturing, and the hope that it would be the difference between victory and defeat. But the real test would come on the battlefields of Europe, where desperate soldiers waited for any advantage against an entrenched and relentless enemy. The first M1917 machine guns arrived in France in early 1918. American soldiers, many seeing combat for the first time, received rapid training in the new weapons. Instructors emphasized the simplicity of Browning's design, showing how to disassemble, clean, and reassemble the weapon took only minutes. Soldiers were impressed by how intuitive the mechanism was. The baptism of fire came during the German Spring Offensive of 1918. German forces, aware that fresh American troops were arriving in large numbers, launched a massive attack, attempting to win before the balance of power shifted irrevocably. Thousands of German soldiers advanced across no man's land in dense waves. M1917 machine guns opened fire for the first time in real combat. The sound was different from that of German Maxim guns, a deeper, more constant roar. The rate of fire was 400 to 600 rounds per minute, creating a barrage of bullets that devastated anything in front of them. American soldiers watched in amazement as the guns fired continuously without jamming. What truly set the M1917 apart was its reliability under extreme conditions. Trenches were a terrible environment for any machine. Constant mud, humidity, fluctuating temperatures, and dust and dirt getting into every mechanism. Maxim machine guns frequently jammed in these conditions, requiring constant cleaning and careful maintenance. The M1917 kept working. Field reports began to reach commanders. One machine gun had fired 20,000 rounds in a single day of battle, with only a short pause to replace its overheated barrel. Another had been partially buried by an artillery shell, dug out, quickly cleaned, and returned to service within minutes. Weapons that had fallen into mud puddles were shaken out, had their basic mechanisms cleaned, and continued operating. The bar, the lighter version, proved equally revolutionary. Soldiers could advance while carrying automatic fire with them, rather than relying on fixed machine guns in the trenches. This fundamentally changed infantry tactics. Assault teams used the bar to suppress enemy positions while other soldiers advanced. It was a completely new concept in mobile combat. The Germans quickly realized they were facing something different. Their intelligence reports mentioned new American machine guns of exceptional reliability. Captured German soldiers reported that their own MG-08 machine guns, while excellent, were more difficult to maintain in field conditions. Browning's weapons had a clear technical advantage. It wasn't just the technical specifications that mattered. It was the psychological effect. Soldiers carrying M1917s or bars felt more confident. They knew their weapons would work when they needed them. This confidence translated into better combat performance. Commanders could plan tactics knowing that automatic firepower would be reliably available. In September 1918, during the Meuse-Argonne offensive, Browning machine guns were present in force. They played a crucial role in breaking through the German defensive lines. The constant sound of hundreds of M1917s firing simultaneously created a deafening roar that dominated the battlefield. By the time the armistice was signed in November 1918, Browning's machine guns had proven their worth beyond doubt. But their story was only just beginning. The end of World War I in 1918 did not diminish the importance of Browning's machine guns. On the contrary, it solidified them as the world standard. Armies around the globe studied American weapons with envy and admiration. John Browning's design had set new standards for excellence in automatic weapons. The M1917 became the standard heavy machine gun of the United States Army, a position it would hold for decades. It was redesignated the M1917A1 with minor improvements based on field experience. Air-cooled versions were developed for situations where a water system was impractical. Each iteration maintained the fundamental principles of Browning's original design. The bar had an equally impressive fate. It was adopted by military forces in over 20 countries. Modified versions were used as hunting weapons and by law enforcement agencies. During the Prohibition era in the United States, both police officers and gangsters used bars. Their automatic firepower made them infamous in urban shootouts. John Browning continued. Working even after his triumph in World War I, he was now in his early 60s, an age when many men would consider retirement, but his creative mind was far from at rest. He developed new pistols, innovative hunting rifles, and continued improvements to his existing machine guns. In 1921, he was in Herstal, Belgium, working with arms manufacturer FN Herstal on a new pistol design. It was a normal day at work in the workshop when John experienced chest pains. He tried to keep working. After all, it was what he had done all his life. But the heart attack was devastating. John Moses Browning died at his workbench, surrounded by the tools and projects he loved. He was 66 years old. His death was reported in newspapers around the world. Obituaries described him as the greatest weapons inventor who ever lived. Military personnel from several countries paid tribute. But the true tribute to John would come in the following decades, when his inventions would continue to shape global conflicts. During the years between the world wars, Browning's machine guns were continually refined. Military engineers made minor adjustments based on years of use. Materials were improved with advances in metallurgy. Manufacturing processes became more efficient. But the core design remained essentially the same as John had created. The M2, A larger 50 caliber version of Browning's heavy machine gun was developed in 1933. This weapon would be perhaps his most enduring legacy. Capable of penetrating light armor and downing aircraft, the M2 combined devastating power with the reliability characteristic of Browning designs. It was such a well-designed weapon that it would remain in active military service for over 90 years. An absolutely remarkable record. As war clouds began to gather again over Europe in the 1930s, armies around the world prepared frantically, and in arsenals across dozens of countries, Browning machine guns were being pulled from storage, cleaned, tested, and readied for another global conflict. The Utah mechanic, dead for years, was about to influence another world war. When World War II broke out in 1939, the Metral Browning machine guns were present in virtually every theater of operation. The M19-9, a lighter, more portable version of the M1917, equipped vehicles, aircraft, and infantry positions. The 50 caliber M2 became ubiquitous, mounted on tanks, jeeps, ships, planes, and fortifications. World War II was fundamentally different from World War I. Instead of static trench warfare, it was a war of rapid movement, tanks cutting through fields, aircraft dominating the skies, Marines assaulting Pacific beaches. Browning's machine guns needed to function in each of these extremely diverse environments. In the North African desert, fine sand penetrated every mechanism. German MG-34 and MG-42 machine guns, though excellent in many respects, suffered from frequent jams. The Brownings continued to function. British and American soldiers developed an almost religious respect for the weapon's reliability. Tank commanders particularly loved the M2. It could fire at enemy aircraft, suppress fortified positions, and penetrate lightly armored vehicles. In the jungles of the Pacific, the war against Japan presented unique challenges. Extreme heat, constant humidity, dense vegetation, and close-quarters combat. American Marines relied on the bar as a squad weapon. In fierce battles on islands like Guadalcanal, Iwo Jima, and Okinawa, the bar's sustained automatic fire often made the difference between capturing a position and being repulsed. American bomber aviators relied entirely on Browning 50 caliber machine guns for defense. B-17 Flying Fortresses carried up to 13 M2 machine guns. When formations of German fighters attacked, the sky filled with red traces. Gunners in turrets swung their guns in complex arcs, firing thousands of rounds per mission. Reliability was literally a matter of life and death. A jammed gun could mean a defenseless bomber. Production during World War II reached impressive levels. American factories produced more than 2 million Browning machine guns in various calibers. Women once again made up a large portion of the workforce, operating precision machinery and performing complex assembly work. The industrial infrastructure created during World War I expanded dramatically. After 1945, while other weapons were retired or replaced by more modern designs, Browning machine guns remained in service. In the Korean War of the 1950s, soldiers used the same M19-919s that had equipped their fathers in World War II. In Vietnam in the 1960s and 1970s, the M2 remained the primary heavy machine gun, now equipping helicopters in addition to ground vehicles. What was remarkable was not just longevity, but continued performance. Military engineers repeatedly attempted to develop replacements for the Browning machine guns. Prototypes were tested, contracts were awarded, new designs were officially adopted. But time and again, soldiers in the field preferred the old, reliable Brownings. The M2 in particular defied all replacement efforts. In the Middle East wars of the 1990s and 2000s, more than 80 years after John Browning observed gas-moving grass, their machine guns were still in active combat. Soldiers in Afghanistan and Iraq mounted M2s on Humvees and at forward bases. The weapon that had faced German planes over Europe now faced insurgents in the desert. The story of John Moses Browning transcends the biography of a simple inventor. It is the story of how an individual with exceptional talent and relentless determination could literally change the course of world history. The weapons he created influenced conflicts that shaped the 20th century and remain relevant in the 21st century. The 50 caliber M2 remains in active service in over 100 countries. No other firearm in history has a comparable service record. From its adoption in 1933 to the present, it has spent over 90 years in continuous military use. Modern. Engineers with sophisticated computers, advanced materials, and decades of additional experience have been unable to create something fundamentally superior to the design John created with paper, pencil, and brilliant mechanical intuition. The gas-operated principle John discovered by observing moving grass became the basis for most modern automatic weapons. Assault rifles like the American M16, the Russian AK-47, and countless others use variations of the system John developed. He didn't just invent specific weapons. He discovered fundamental principles that defined an entire category of technology. But beyond the technical specifications and service records, there's something deeper to Browning's story. It's about the nature of genuine innovation. John had no formal engineering education. He never attended university. He didn't have access to sophisticated laboratories or research teams. What he did have was careful observation, creative thinking, and a willingness to test ideas repeatedly until they worked perfectly. His design philosophy was elegant. Create mechanisms with as few moving parts as possible, use natural forces instead of fighting them, build tolerances into systems so they continue to function even when individual components wear out. These principles seem obvious in retrospect, but they were revolutionary in their time. John registered 128 patents during his lifetime. In addition to machine guns, he created pistols, rifles, shotguns, and even automatic cannons. Many of his designs continue to be manufactured and sold commercially more than a century later. The Browning high-power pistol, completed after his death by his apprentice Dieudonné Sève, was adopted by more than 50 national armies. There's a poetic irony to Browning's legacy. He was a fundamentally peaceful, deeply religious man who believed in using his talents for constructive purposes. But his most influential creations were instruments of war. Millions of people were killed by weapons based on his designs. He never publicly expressed conflict about this, but it's hard to imagine he didn't reflect on the consequences of his inventions. Perhaps the best way to understand John Browning is to see him as a pure problem solver. He saw mechanical challenges and couldn't resist solving them. The fact that his solutions were used in war wasn't his primary goal. It was the inevitable consequence of living in an era of global conflict. Had he been born in a different era, perhaps his genius would have been applied to agricultural machinery or industrial tools. The mad mechanic who transformed a hunting rifle into a war legend never considered himself special. To him, it was just work. But his work changed the world in ways he could never have fully anticipated. And more than a century later, his legacy continues to soar.